Welcome back to the Deep Dive. Today, our mission is, well, it's a very tactical one. It's designed specifically for you as you prepare for the Agentforce Specialist Certification exam. We're going to move beyond just knowing what the features are and really try to understand the precise technical nuances of configuration and deployment.
That's exactly right. The source material you've gathered, those tough practice questions, they really show us where the conceptual flexion points are.
Right.
The exam doesn't just test breadth, it tests a kind of surgical precision. So today, we're extracting those critical details, the often missed technical facts to make sure you know the definitive answer and, more importantly, the reasoning behind it.
Okay, so we're slicing this deep dive into what we see as the 4 essential pillars of Agentforce. We'll start with the data foundation, so the knowledge that grounds the AI.
Which is everything.
Then we'll look at the internal logic,
Yep.
agent architecture and configuration. After that, we'll get into generative AI strategy, focusing on prompt templates and their constraints. And finally, we'll tackle the non-negotiable layer, control, trust, and security. This should be your shortcut to mastering the high-stakes facts.
And we absolutely have to start with the data foundation. I mean, if the agent doesn't have the right access to the right data and format it in the right way, nothing else is going to work.
Okay, let's start there then. Let's unpack one of the most fundamental requirements. Say an organization wants its agent to answer questions using the actual text from past resolved cases.
Yeah.
You know, the resolution notes, case descriptions. What is the absolute non-negotiable technical prerequisite for that?
This is a classic distinction, and it's one that really separates basic data management from, true AI grounding. You have to recognize the difference between structured data and unstructured text.
Okay.
Standard data model objects, DMOs, they're great for structured data. Things like IDs, numbers, status fields, dates.
The stuff you'd find in a spreadsheet column.
Exactly. But when you need the AI to actually read the data to understand the meaning and context of a past resolution, you have to use an unstructured data model object, a UDMO.
So if I just use a standard DMO on the case object for those big text fields, what happens? What's the failure mode there? Why doesn't that work for a modern semantic search?
Because a DMO is optimized for database querying, not for understanding language. If you tried to query a DMO index on case notes, the system would just fall back on rigid keyword matching.
So it would just be like a Control-F search.
Pretty much. It would find cases that mention the exact words printer driver, but it wouldn't find cases about, say, output peripheral software update, even if that's what the user was really asking about. A UDMO, on the other hand, is designed specifically for indexing text-heavy content with semantic understanding.
I see. The AI needs the text formatted for linguistic analysis, not just for database querying. So the required implementation path is create a UDMO based on the case object, and then, this is the key part, create a semantic search index on that UDMO.
That's it. That index is what allows the agent to retrieve and reason over the text based on its meaning, not just by matching exact keywords.
So if you miss that UDMO step, your semantic retrieval just fails. The agent basically can't learn from your company's history of solved problems.
Precisely. For any text-heavy grounding, UDMOs are the absolute foundation.
Okay, let's talk about a frequent stumbling block with indexing. Documents, attachments. We see this scenario a lot where the agent can summarize the main knowledge article perfectly, but it completely ignores any PDF or Word attachments linked to it. The content's critical, but the agent just seems blind to it. How do we fix that? How do we make the agent aware of what's inside those files?
This is a really deep configuration detail inside the Data Cloud search index setup. The default configuration for an index usually only captures the primary article body text.
Right.
To include the text that's actually inside the associated files, the Agentforce specialist has to go in and find and enable the Include Attachments option. It's a checkbox right within the Data Cloud search index configuration for the knowledge object.
So enabling that option is step one. But I think there's more to it. There's a specific object that actually holds the extracted text of the file itself that needs to be indexed. What is that technical object name?
That is step 2, and you're right, it's mandatory. You must select the content document version UDMO.
Content document version.
Right. Think of it this way. The knowledge article is the container, But the content document version object, that represents the raw, extracted index text from the file, like the PDF.
I see.
If you miss indexing this specific UDMO, the agent knows a file exists, but it can't read what's inside it. It makes the attachment functionally invisible to the reasoning engine.
So by indexing content document version, you're ensuring the agent can retrieve and reason over all those critical details that are buried in the associated documents.
It's an essential combination. The include attachments toggle and the content document version object. You need both.
Okay, moving on to the knowledge base itself. We see requirements that really stress this fundamental integration with Agentforce. If support agents need to ask questions about product tutorials and guides, that content has to live in a specific system, correct?
Absolutely. The official, secure, and integrated source of company knowledge for Agentforce has to be published as knowledge articles right within Salesforce Knowledge.
So if that content, the guides and tutorials, is just sitting on a shared drive somewhere or in another system,
It has to be brought in, it must be ingested and indexed via Data Cloud, and ultimately it has to adhere to that knowledge object structure for secure, company-specific grounding to work reliably.
and when you're configuring the data library that controls this access, which is like the agent's gateway to the knowledge, there are two settings related to security and trust that seem to come up a lot. Let's say a company needs to restrict indexing to only publicly available articles, and they also want transparency. What settings are required?
Okay, two things. For security and access control, the specialist must enable use public knowledge article in the data library settings. This is really crucial for controlling what knowledge gets exposed, especially if you have unauthenticated external agents or users.
Right, you don't want internal-only documents getting out.
Exactly. And then at the same time, for accountability and just building trust in the AI's output, they have to enable show sources.
What does that do?
It forces the large language model to cite the specific knowledge article it used for grounding its response. It provides a link back to the source, which is vital for validation and for compliance.
Okay, so we've established the internal data foundation. But modern setups often involve integrating complex external intelligence.
Yeah.
Let's look at a scenario where you're bringing in inferences from an external model, say an XGBoost classification model that was trained on Databricks.
Mm-hmm.
And you want to bring that into Data Cloud as a standalone DMO, maybe for personalized product recommendations. What's the required integration path for that?
This is a great question because it tests that seamless MLOS integration that Data Cloud provides. We don't want to be exporting data and uploading it manually. We want a live service.
Who was the setup?
It's specific. The data science team must first create the serving endpoint in Databricks. That endpoint is the queryable gateway to the live model.
Okay.
Then, the AI specialist has to configure the consumption of that endpoint using Model Builder, which is a tool inside Salesforce Data Cloud.
So Model Builder doesn't actually host the model itself. It just makes the external model's output operational inside Data Cloud.
That's a perfect way to put it. It treats the Databricks model as a service that generates consumable data, which then becomes a DMO that you can use for grounding or other actions. It streamlines the whole process of operationalizing external models.
Right, ensuring that the latest recommendations are always available for Agentforce to use in real time without any clunky data movement. Now let's tackle unified customer activity. If we're tracking web activity page views, clicks, purchase history in Data Cloud, and we want to use that dynamic real-time data for, say, hyper-personalized prompt templates, how do we correctly leverage that activity data?
This requires marrying Data Cloud enrichment with Prompt Builder's grounding capabilities. You can't just point a prompt template at the raw activity stream. You need to define a pathway.
Which is?
It's a three-step flow, and honestly, the first step is the most critical part of the setup. You must add the activity records as an enrichment-related list to the contact object in Data Cloud.
Okay, so you're linking the activity stream directly to the contact record.
Yes, that's the link. Then, step 2, you pass that contact record into your prompt template workspace. And third, you use what's called related list grounding in the prompt template itself.
And that grounding mechanism pulls the specific recent activity from that enriched related list just for the contact being analyzed.
Exactly. It feeds the LLM the necessary context for deep personalization. The key insight is that the activity data has to be structured as a queryable related list on the object you're grounding the prompt with. The LLM won't go hunting through raw Data Cloud tables. It needs that pre-linked, enriched path.
Without that defined path, the LLM just won't retrieve the data at runtime, and the activity data becomes useless for grounding.
Correct.
Okay, let's pivot now from the data foundation to the agent itself. how it interprets user intent, controls its actions, and how we deploy it. This seems to be where the Agentforce reasoning engine is really different from older conversational systems.
Very different.
Let's start with the agent action selection logic. When a user enters a complex query, the engine runs through a decision hierarchy. Can you walk us through that process? What's the primary decision maker and what's the fallback?
The core logic really relies on the sophistication of the large language model. First, the LLM analyzes the user's intent, and it tries to select the most appropriate topic and action based on its training and the guidance we provide.
So if there's a high confidence match to a predefined action, it just executes it.
It executes it. But the really interesting part is what happens when the user's request is unique or a bit outside the scope of the predefined actions, and the LLM can't find a high confidence match.
Right. This is the point of conversational continuity. What happens then?
This is the critical fallback mechanism. If there are no matches to a specific action, the LLM doesn't fail. It doesn't route to a generic error message. Instead, it attempts to generate a direct, unguided answer to the user's request, using whatever grounding data is available.
So it prevents those conversational dead ends.
Yes, and it leverages the LLM's vast knowledge, making sure the conversation flows seamlessly. This is a massive difference from older bot systems where a failed match meant an immediate pivot to a human agent or that, I don't understand message.
The system tries to self-correct and use its generative power.
Exactly. And this intent-driven approach means the success of the agent relies less on rigid flowcharts and more on the quality of the natural language descriptions we give it.
Speaking of descriptions, when the LLM is choosing a topic, what two pieces of information are most important for matching user intent? You have the topic name, the classification description, and the scope.
It's the topic name and the classification description. And while the name is useful for us to identify it, the classification description is absolutely essential for the LLM.
Why is that?
Because this is the natural language context. It's a few sentences explaining what the topic is designed to handle, what types of user requests it addresses. The reasoning engine analyzes the user's input directly against this description to classify the intent. If that description is vague or generic, the LLM is going to misfire.
So the specialist really needs to think of the classification description as the core instructions for the LLM on how to categorize incoming user intent.
That's a perfect way to frame it.
Okay, let's drill down even further to the action components. What's the most critical component of a custom agent action? The part that provides guidance on when and how to use it.
That core component is the instructions. The instructions are a set of directives that you provide to the LLM's reasoning engine specifically for that action. They define the inputs it needs, the conditions that must be met, and the precise outcome you want. Poorly written instructions lead to an unreliable agent.
This brings us right to troubleshooting. If the agent successfully selects the correct topic, so the classification description worked, but then it triggers the wrong action within that topic, where does the specialist need to focus their testing?
The problem there is internal differentiation. Since the intent, the topic, was matched correctly, the issue lies in the fine-grained distinction between the available actions.
So it's not the topic, it's the action choice.
Right. The specialist has to focus entirely on testing and iterating on the action instructions for all the actions within that misbehaving topic. They need to make the instructions for each action distinct enough that the reasoning engine can reliably select the correct one based on subtle differences in the user's input.
Let's talk about session control. We often see scenarios where an agent successfully gathers preferences, like a user's preferred shipping speed or a dietary restriction, but then it forgets that information later in the same conversation. How do we make sure that data persists reliably?
You can't rely on the transient conversational memory for critical preferences. It's just too mutable. The solution is explicit storage using a context variable.
A context variable.
Right. Context variables are designed specifically to capture and store customer preferences or other crucial session state data. This data then persists for the entire duration of that session, so the agent can reliably recall and reference it for any subsequent actions response.
Okay, understood. So context variables are like the agent's short-term notepad.
That's a great analogy.
Moving to architecture, let's discuss the Model Context Protocol, or MCP. It's a technical term, but what's its function?
Yeah.
Why is it so important for enterprise integration?
MCP is fundamentally about enabling dynamic, runtime integration and discovery. It allows AI agents to discover and invoke other services, external APIs, or even different models dynamically right at the moment the agent needs them.
Can you give us an analogy? Is it like a universal switchboard?
That's a very good way to put it. It's an intelligent switchboard and a directory combined. The agent, instead of having all these hard-coded connections, uses MCP to dynamically find a service that matches its current requirement.
What's a good example of that?
The best illustration is a legal assistant agent. It might use MCP to dynamically find a document classification API, which could be hosted anywhere, to analyze a case file that's just been uploaded. It's dynamic, secure service integration on demand.
That makes MCP more of an infrastructure component then, defining how the agent looks outwards for capabilities,
Yeah.
rather than just an agent-to-agent communication tool.
Precisely. It's about leveraging the entire ecosystem of services at runtime.
Now for the deployment side, which is often tested with these painful recall facts, when a developer deploys agent components topics, instructions, actions, using the Salesforce CLI, they need a specific metadata component name in their package.xml file. What is the precise name for the Agentforce bundle?
This is a high-stakes recall item. It's testing if you know the current non-legacy name. The required metadata component is jnipaname.fbundle.
jnipaname.fbundle.
Yes, which represents the Geno Planner bundle. And we have to caution you, the learner, to avoid the older names. You might see Einstein Planner bundle or the legacy bot name bot bundle. For modern Agentforce components, the correct designation is jnipaname.fbundle.
Okay, we've built and defined the agent's logic. Before we activate it, we have to test it. If a specialist needs to evaluate multiple real-world user utterances against custom actions to ensure they perform reliably, what's the essential tool for that kind of scalable batch testing?
The required tool is the testing center.
The testing center.
Right. It's designed specifically for this kind of regression testing and validation. It lets you input dozens or even hundreds of sample user inputs and then automatically run them through the reasoning engine to verify that the correct action is selected every single time.
So it's critical for refining those classification descriptions and action instructions before the agent ever talks to a real customer.
Absolutely. It verifies consistency, which is crucial for a production-ready agent.
So Prompt Builder is more for configuration and single test checks, but the testing center is for scalable validation.
Exactly. Now let's wrap this section with a hard rule about data access. Regarding data libraries and a single agent, what's the crucial restriction?
I remember this one being a very firm rule.
It is. An individual Agentforce agent can have only one data library assigned to it at a time.
Only one.
Just one. Your org can have multiple data libraries for different business units or purposes, but a single agent must be grounded in the consistent set of sources provided by that one library. It simplifies the provenance of the data and ensures consistency in the agent's knowledge base.
Okay, moving into Section 3, Generative AI and Prompt Template Strategy. This is the heart of what the LLM actually produces. We need to clearly define the different prompt template types and understand the critical technical constraints of the data we feed into them.
Let's start by differentiating field generation from record summary. Where should a specialist use field generation?
Field generation is the choice when your goal is to automatically populate a specific single field on a Salesforce object.
Example.
For example, generating content for the description field on an account, or summarizing an interaction into a simple summary field on a custom object. It's really designed for highly structured, single-field output, mainly to improve an agent's data entry efficiency.
The key there is single structured output. Now contrast that with record summary. If an organization needs to generate a detailed, cohesive narrative or a summary based on multiple fields from a complex record, say, generating accurate product descriptions for marketing, why is record summary the better choice?
Because record summary is engineered specifically to pull from multiple disparate field features, specs, pricing, you name it, and weave them into a single, fluid, detailed narrative. It generates a holistic overview that's designed for external consumption or detailed internal analysis. It ensures consistency and accuracy across all the descriptive content you're deriving from that one record.
Excellent distinction. Now let's move to communication templates. If an admin needs to generate personalized, targeted email drafts using an LLM, incorporating customer interaction data and allowing for reuse across different segments, which template type supports that?
That immediately points to the specialized sales email prompt template type. That template is built specifically for generating personalized AI-powered email drafts, leveraging data while keeping a reusable structure.
And if we want to make those emails hyper-relevant, say based on a customer's stated interests and past product interactions, what's the complete technical solution for that?
The solution requires combining the template with grounding. So you'd use a custom sales email template, which is grounded with interest and product information. The template gives you the structure, but the grounding is what injects that specific, real-time context you need for true relevance.
Right.
Grounding is powerful, but it has these strict technical limits dictated by the foundation models. When you're configuring a prompt template, what is the single most important technical consideration regarding the grounding data size?
This is a critical point that can lead to silent failures. The specialist must review the model limitation in Prompt Builder versus the grounding data size.
What do you mean by model limitation?
Every foundation model has a finite token limit. This limit dictates the maximum amount of input the LLM can process, and that input includes your prompt instructions plus all the retrieved grounding data.
So what's the real-world consequence if a specialist overgrounds a prompt? They pull in too much related record data or a huge knowledge article, and they exceed that token limit.
The consequence is truncation. The system might silently just truncate the input data.
It just cuts it off.
It just cuts it off. This means the LLM only gets the first portion of your grounding data, and it might miss the crucial piece of information that was at the end of a long record or a lengthy related list. The LLM will then generate a response that sounds confident, but it's factually incomplete or incorrect because it simply never saw the full context.
That's a huge administrative risk.
Yeah.
It really demands careful management of data retrieval.
It makes the specialist responsible for being a data minimalist, really. You have to ensure only the most relevant, essential context is passed to conserve those tokens.
Okay, let's look at record snapshots grounding. This uses field values from the specified master record. What specific type of data is actively filtered out of the snapshot to keep the prompt clean and relevant for the LLM?
The system is pretty intelligent about prompt clutter. The key thing to remember is that empty data, so fields without any values, nulls, that gets filtered out.
Automatically.
Salesforce actively prunes null or empty fields from the snapshot before ingestion. It's a crucial efficiency mechanism, saving valuable tokens by preventing the LLM from having to process irrelevant data.
And here's a technical detail that often trips people up, especially those familiar with modern Salesforce development. To ensure the correct fields are available for the record snapshot, what preparation is required?
This is a classic exam trick. You must configure the page layout of the master record type.
The classic page layout, not dynamic forms.
Not dynamic forms. Despite how prevalent dynamic forms and field sets are, Record Snapshot's grounding explicitly ignores them. It relies only on the classic underlying page layout configuration assigned to the running user's profile to determine which fields get included in the snapshot.
So when you're dealing with grounding, you have to temporarily revert your thinking to the classic page layout for field availability.
Exactly. The system prioritizes stability over using the newest front-end configuration in this case.
Okay, finally for this section. What if a company needs to incorporate highly complex CRM data, say, a list of nested product components, as well-formatted JSON in a prompt, to make sure the LLM parses the structure correctly?
Right. Standard merge fields will just dump raw text, which an LLM could easily misinterpret.
So what's the solution?
The required technical solution is to use Apex code to return a JSON-formatted merge field. An Apex method can execute complex SQL queries, structure the results perfectly into a valid JSON string, and then expose that formatted string as a callable merge field right inside Prompt Builder.
That gives the developer maximum control over how complex data is presented to the LLM.
Complete control.
Okay, section 4. This focuses on the non-negotiable layer of control, trust, and security. For any enterprise AI, establishing secure data use and transparent outputs is absolutely paramount.
It is. Let's start with the Einstein Trust Layer's output safeguards. Toxicity scoring assesses content safety. What's the critical numerical exam fact about this scoring mechanism?
The specialist has to recall that a safety category score of 1 indicates the content is deemed safe. That numerical standard is a key recall point for the exam, with the score decreasing towards 0 for increasingly unsafe content.
That numerical precision is high stakes. Okay, now, let's say a company needs a feature that supports enhanced data protection, ensures the AI uses up-to-date info, and securely includes relevant Salesforce record information in a prompt. What's the specific trust layer feature that combines all of those needs?
That combination of current data, secure retrieval, and relevance, that points directly to dynamic grounding with secure data retrieval.
And what does that do?
That feature ensures that only the relevant, authorized, and current Salesforce record data is retrieved right at the moment the prompt runs. It enforces all the permission models and maintains data integrity within the LLM's context.
Right.
Now, security often boils down to execution context. Let's tackle what might be the most critical security implication in this whole deep dive. Custom agent actions that call flows. For instance, a flow to check a customer's real-time order status. What is the absolute rule about flow execution mode in Agentforce?
This is the massive insight the specialist has to internalize. When a custom agent action calls a flow, the agent will always run that flow in system mode.
Always.
Always. And the consequence of this is profound. The running user's data, access, their sharing rules, their field-level security, their object permissions, none of it affects the data that gets returned. The flow executes with elevated system privileges.
Whoa. So the flow can completely bypass security rules that would normally restrict the human agent or the customer.
Yes, it's a necessary mechanism for agent reliability, but it demands extreme caution from the specialist. It's a powerful administrative bypass. You have to ensure that the flow logic itself is robustly designed to handle and filter data securely, because the execution environment will grant it unrestricted data access, regardless of who started the agent interaction.
Okay, that's a big one. Now let's look at user-level access. If a sales user can't see the generative AI-enabled field icon next to a summary field, even though the field is configured correctly and other users with the same profile can see it, what specific permission set is likely missing?
This is a classic issue of missing feature-specific enablement. The most likely cause is that the user does not have the prompt template user permission set assigned.
The prompt template user permission set.
Yes. It's a specific feature-level permission set that's mandatory for interacting with generative AI fields tied to prompt templates, even if their general profile permissions seem to grant access to the field itself.
That's a crucial distinction, general object access versus specific feature enablement. Now, what about runtime failure? If knowledge grounding works perfectly in Prompt Builder at design time, but then fails completely in Agent Builder and Experience Cloud, at runtime, what's the missing permission?
So the agent is failing at the point where it's trying to query the index data. The specialist needs to troubleshoot the Agentforce service agent user. The solution is to ensure the Data Cloud user permission set has been assigned to that Agentforce service agent user.
Why does that user need it?
Because without that specific permission set, the agent user lacks the necessary credentials to query the Data Cloud index where the knowledge articles are stored at runtime. It works in Prompt Builder because you, the admin, have the permissions, but the automated agent user doesn't.
That's a common pitfall, forgetting to assign the necessary runtime permissions to the service user itself.
Very common.
Okay, finally, if an Agentforce service agent is integrated into a process with a new custom object, say a custom warranty claim object, what foundational access is needed for the agent user?
The basic principles of Salesforce security still apply, even to AI agents. The agent user needs the foundational data access. It needs read access to the custom object assigned via its permission set. Without that object-level access, the agent just can't interact with the data required by its actions or any flows related to that object.
Okay, our final section. Let's focus on the specialized productivity tools Agentforce offers and the specific set of procedures required to deploy them effectively. The specialist has to know which tool is purpose-built for which job.
Let's clarify the email response generators first. If the goal is to provide personalized, knowledge-grounded, AI-generated email responses to cut down the time agents spend drafting, what capability handles this?
That functionality is encapsulated by Einstein Service Replies for email. It uses the knowledge base to draft accurate, context-aware responses, automating a big portion of the agent's writing task.
Okay, now let's shift to live conversation. For quick, relevant responses grounded in the knowledge base during a live chat interaction, which feature analyzes the conversation in real time and suggests replies directly to the human agent.
That real-time conversational assistance tool is Einstein Reply Recommendations. It monitors the chat flow and surfaces these knowledge-backed suggestions that the human agent can use instantly. It ensures speed and consistency, especially during high-pressure interactions.
And what if a sales manager needs a solution to contact leads at scale with hyper-relevant solutions and customized communications, designed specifically for automated, targeted outreach?
That specialized tool is Einstein Lead Follow-up. It focuses on automating personalized engagement with leads, prioritizing follow-ups, and scaling customized communications across the whole sales funnel.
Got it.
Now let's discuss work summaries configuration. If a specialist is setting up work summaries for enhanced messaging in a sandbox, and it has to be deployed to production, so we need deployable metadata, what are the 3 required configuration steps they must complete?
This is a great test of understanding deployable versus administrative settings. The 3 required steps are: 1, create custom fields on the messaging session object to store the issue, resolution, and summary that the AI will generate.
Okay, custom fields first.
2nd, create a quick action that is configured to update these new fields you just created. And 3rd, add the wrap-up component to the messaging session record page layout that makes the action visible and accessible to the user.
Fields, action, and layout component. All deployable metadata, all essential for the feature to work in the target environment.
Correct.
We covered deploying the core agent bundle. Now, how do we make sure that generative AI-enabled fields, the ones tied to those record layouts, are visible and usable in the Salesforce mobile app?
Since they're part of the page layout experience, the required configuration is to enable dynamic forms on mobile. This ensures that the dynamic layouts containing those AI-enabled fields are rendered correctly and available for mobile users.
Next, a specific data cloud indexing issue. If a new PDF ingestion setup is working, but a required field is missing when you're configuring the retriever settings, what's the fix?
This just confirms where the agent pulls its data from. If the field is missing at retrieval time, the specialist has to update the search index to include the desired field. The search index is the source of truth for the retriever, so it must be explicitly configured to include that data point.
Okay, and finally, for measuring business value. If a company needs clear insights on usability, performance, and overall organizational adoption of the agents they deploy, what's the recommended tool for tracking those metrics?
The dedicated tool for optimizing and improving the business case for your agent fleet is Agentforce Analytics. This provides the specific metrics needed to refine the agent's performance and track its adoption across all your user groups.
Well, we've completed a pretty comprehensive tour. We spent time on the why of each crucial technical decision.
From the foundational difference between DMOs and UDMOs to the complex security implications of system mode flows, yeah, we've really focused on the nuanced facts the exam demands.
And what stands out most clearly to me is the administrative responsibility. We've learned that the specialist has to secure the agent against silent failure by mitigating that token limit risk, and against over-permissioning by understanding that flows run in system mode.
Right. And the ability to deploy the correct metadata, that genipyname.f bundle, and ensure the correct runtime permissions, like the data cloud user perm set on the agent service user, those are the technical differentiators. Mastering these specific configuration details is the key to demonstrating the specialization the certification requires.
Remember, the exam tests your knowledge of the precise implementation pathway. You have the knowledge now, go apply it confidently.
Before we close, consider this one final provocative thought, building on the dynamic nature of agent control. We discussed how the agent relies on the LLM for action selection and the critical importance of crafting clear action instructions.
Right.
So, if the future of Agentforce training is shifting away from rigid declarative programming and more toward refining natural language interpretation, does the Agentforce specialist's primary skill set now shift? Are they less of a developer who codes flows and more of a linguistic engineer who optimizes the reasoning engine's understanding through better instructions and rigorous testing center analysis?
We'll leave you with that thought as you secure that certification. Good luck, and thank you for diving deep with us.